looking at string problems. So write a function that reverses a string. The input string is given as an array of characters, S. You must do this by modifying the input array in place with O of 1 extra memory. So this is what we got. They want us to do it in reverse. So there's a couple ways to do this, huh? So they give you a string, and strings are immutable, so you can make a new string by saying, well, look, what they've given us is they've given us an array of characters. So if we want to reverse an array, well, there's a couple ways to do that. One way is to turn this this array into just a single word. So we're going to join it. We're going to join it back together on nothing. So that should give us a string, and then dot reverse. Well, let's try it with just reverse first. I don't know that we need to do all that nonsense that we got there. And return. I don't know. Return string. Just hanging out doing this shit. Okay. Okay, so yeah, you can do it just like this. Can you simply return it like this? Can you? Yeah, you can just do it in one line like this. Can you do it with 2 pointers? Let left equal 0. Let right equal s dot length minus 1. And for I equals 0, I is less than s dot length, I plus plus. And then we're going to compare the ones on the, we're going to exchange the ones on the end. So this one is going to be assigned to this one. And you can do that with a dumbbell assignment, is what I call it. And so you're going to do A, B, and then B, A. So that's how you assign them to each other in one line. So how do we find H? Well, H is S of left. And then what is B? S of right. And then what is B? S of right. And then what is A? S of left. And so they get assigned to each other in this way. And we keep doing this until we get to the middle. And we exchange them and then return S. And does it work? No. What happened? The output. So these got exchanged. And then E and L were not exchanged. So we got halfway there. It tells me we returned a bit too early, I think. So why? So why did we stop early? I plus plus. S of left, S of right. Return S. Less than equal. Possibly. We did this one. What's going on with this one? Left. This is the last character. This is pointing to the first character. This is pointing to the last character. S dot length minus 1. Let I equal 0. S of left. I don't think that's the reason, but I'll try it. I is less than S dot length. I plus plus. S of left, S of right, S of right. So this S of left becomes S of right, and S of right becomes S of left. Oh, we need to move our pointers. We're not moving our pointers. Cannot stress enough how important that is. Moving our pointers. Time limit exceeded. Well, I'm sorry, but I think this would have worked. Whatever. Okay, so reverse an integer. Well, let num equal x dot to string. We're going to turn it into a string, and then dot reverse, and then to int return num. I think. I don't know. I'm just making that up as I go along. It's a string reverse. Split dot reverse dot join like we found it. I don't even know if toInt exists, but that's just what I'm gonna try. It's not a valid. Parse int return parse int num let integer equal parse int num return the integer return the integer. Okay, what about with the sign? You can't do it with the sign. There's a special sign, math, sign. Don't worry about it. I'm not going to worry about that one. Valid palindrome. So a phrase is a palindrome if after converting all uppercase letters to lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backwards. Alphanumeric characters include letters and numbers. Given a string S, return true if it is a palindrome or false otherwise. Well, the first thing you gotta do is make it into just a vanilla array. Let my array equal S dot split split it on nothing, and then we can dot replace. So this is our regular expression. And how do we make a regular expression? 2 slashes. Inside the slashes, square brackets. Inside the square brackets, we're going to want to remove a to z 0 to 9. I think it's like this. And then a. We're going to, yeah, that's for uppercase. So we want to make everything to lowercase. And so no uppercase after we made things to lowercase, 0 to 9, comma, G for a global flag and replace it with nothing. So you don't stop at the first one, that's very important. And once we've done that, we have an array that we can operate on that does not include uppercase or zeros or nines. And so now we can check if it's a palindrome. So it must be symmetrical. That's what we know about palindromes. They're symmetrical. Less than s dot length I plus plus. Okay, so now we need a left pointer and a right pointer. And if ever s of left does not equal s of right, if that happens, you can return false. Else, left plus plus, right minus minus. Two lowercase is not a function. You can only do this on, I think we have to do it before it becomes an array. It's all about the order of doing things. So we never return true. So if we get to the end, we can return true. So something I'm not doing. Works for this one. Well, that one was easy. Of course it works for that one. Regular expression. It's not working like I thought it would. So let's check it out. Not everything that the up caret means not. where are we? Everything, replace everything that's not A to Z 0 to 9. Pretty sure. Chat GPT, just fucking tell me. Yes, it's regular. I knew it was a regex issue. Yeah. Loop, whatever. Index misalignment. Pointers should align with the filtered string R, not S. Yeah, we're iterating over array. I think that's the main problem here. R and R. Array. What was the regular expression issue? Everything not A to Z. And using the lowercase. The fuck? They use a while loop. Okay. Whatever. Looks good. Valid anagram. Given two strings S and T, return true if T is an anagram of S or false otherwise. So let T equal T dot split, and then dot sort, and then join, and let S equal S dot same thing, and if T does not equal S, then return false, else return true. Okay, that's enough for today. After all, it's a snow day.